Hello, this is Mr. Stansbury. I'm going to take you through the odd problems on the 6-2 graphs of inverse functions worksheet. For all of these, let's see, 1 through 5, state if the given functions are inverses. Show your work. So to figure out if the functions are inverses, remember we have to plug, like say we have to plug this one in for this x here, and then we have to take this one and plug that one in for this x here, right? So it doesn't matter which one we do first. We have to check them both. Unless you get no on the first one, then we are done. Because remember, they have to both, if we plug them into each other, they both have to come out as an x, right? So let's do this. Let's do negative 2x minus 4. Put that in for this other one here. It doesn't matter which one you do first. Negative x plus 2 over 4, right? So this is going to replace this x right here. So super important when you do this, you got to make sure that you put negative in front of that, and then it's negative 2x minus 4, and then we got the plus 2 over the 4. So distribute this negative to both parts here, which basically turns those both into positive, so we get 2x plus 4 plus 2 all over 4, right? So 2x plus 4 plus 2 is 2x plus 6 over 4, and what does not come out of that is x. So let's see, 2x over 4, that's going to be 1/2 x, plus 6 over 4 is 1.5. That does not equal x, so no, they are not inverse functions. Okay, so as soon as you get one that does not equal x, you don't even have to worry about checking the other one, because they both have to equal x when you plug them into each other. All right, let's try this one here. Let's give ourselves a little bit of room since we've got some extra room over here, just in case we need it. Okay, so we just plug one into the other, so let's do negative 15 minus x over 3. That's all going to go in for this x here on negative 3x minus 15, right? So negative 3, this negative 15 minus x all over 3 goes in for this x right here. So that's negative 15 minus x over 3. And then we got this negative 15 that follows along right there. So let's do this. The 3 and the 3 reduce down to 1. And then this negative times this negative and this negative times this negative turns those both into positive. So it's going to be 15 plus x minus 15, and then guess what happens when we add those together? 15 and negative 15 turn into 0, so we get plain old x that comes out. So one of them for sure works. Let's see if it works the other direction as well. So make a new function machine, and then now this negative 3x minus 15 is going to go into this function, negative 15 minus x all over 3. So this goes in for this x right here. So we got negative 15 minus, and that's negative 3x minus 15 all over 3. Okay, so let's distribute this negative through to both parts here. So that leaves us with negative 15 here. Negative times negative 3x is plus 3x. Negative times negative 15 is plus 15 all over 3. Okay? The negative 15 and the positive 15 cancel out. So we get 3x over 3, which guess what happens when you take 3x and divide it by 3? We get x out. So since they both end up equaling x when you put them into the other functions, then this one these are inverse functions. State if the given functions are inverses. So instead of is, that would be they are inverse functions. Okay, and then for 5 here, same idea. Let's plug these things in, see what we get. I'm going to plug x plus 2 over 3 in for my x into the 3x plus 7. So this goes in for that. 3 times x plus 2 over 3 plus 7. This 3 and this 3 reduce down to 1, so we get x plus 2 plus 7. So when we go to simplify that, x plus 2 plus 7 is x plus 9, which does not equal x. So we can stop right there and say not inverse functions. Okay? All right, second back page here is find the inverse of each function, show your work, and then graph the function and its inverse. So let's graph each one of these. So we'll graph the regular function in blue, and then we'll do the inverse function in red, let's say. So let's start, we can just graph this one right off the bat, -1, and then it's -1/2, so that means go down 1 over 2. Down 1 over 2. And then we can make ourselves draw ourselves a nice little straight line there. Okay, and then so now we need to find the inverse function, right? So that's where we switch the x's and the y's, right? So that's going to be x equals -1 minus 1/2 y. So solve this thing for y, add 1 to both sides. X plus 1 equals -1/2 y. To get rid of the negative, we got to multiply by a negative, and to get rid of the 1/2, we got to take 2 of those 1/2s to get it back to 1. -2 times x is -2x. -2 times 1 is -2. The negative times the negative turns into a positive, and then half of 2 is 1. So there's our y. So this is our inverse function. So again, officially notation-wise, f of -1. The inverse of f of x is -2x minus 2. So let's see, we graph this one. We get this right here. And then we do -2 down 2 over 1, down 2 over 1. And then now we're going to draw ourselves a nice straight line through those. And we get about that. Right? And then if we draw our let's see, I'm going to draw this in purple, I suppose. Let's see, maybe we'll do it in, let's do it in green. So we draw our y equals, oops, I didn't go straight. We draw this, our y equals x, draw that right through, and you can tell that it is pretty darn close to being reflecting. If we were to draw our lines perfectly straight, which is not perfectly straight through all those points, which is not super easy to do, but we definitely are right in that neighborhood right there. Okay, let's see, number 9. Let's graph this one here, starting at 2, and then it's -1/2 n, so that means go down 1 over 2, down 1 over 2, so forth and so on. And we could take that, draw ourselves a nice straight line there. And then now we got to do the inverse function. So that's going to be x equals -1/2 y plus 2, right? Because the the n in this case is the x, so we turn that into the y. So anyway, solve this thing for y. Subtract 2 from both sides. X minus 2 equals -1/2 y. To get rid of that -1/2, we got to multiply by a negative to get rid of the negative, and then half of 2 will give us 1, just like what we did over here. So -2 times x is -2x. -2 times -2 is plus 4. Negative times the negative is positive. Half of 2 is 1, so there's our y, and that's a 4, not a y. Right? So officially this means g to the negative first. The inverse of g of x is -2x plus 4. Right? These are our inverse equations. So to do that one, we start at plus 4, and we go down 2. There's no number underneath, so it's down 2 over 1, down 2 over 1, so forth and so on. We draw ourselves a nice straight line through those, roughly right there. And then if we are to draw our y equals x line right through the middle there, we can see that it reflects over, so I'm feeling really good that that's our correct inverse function. Okay? All right, last one, number 11 here. Let's graph this one here. At plus 4 is the y-intercept. It's -2, so it's down 2 over 1, down 2 over 1, so forth and so on. Graph this line here. Put lines straight through there. And now let's find the inverse of that. So that's going to be x equals negative 2y plus 4. Solve this thing for y, so subtract 4 from both sides. X minus 4 equals negative 2y. All right, and then divide everything by negative 2. Right, and so that's negative 1/2 x. Negative over negative is positive. 4 divided by 2 is 2 equals our y. So that means f to the negative first. The inverse of f of x is negative 1/2 x plus 2. Start at positive 2, down 1 over 2, down 1 over 2. And then we're going to draw our graph of that there. Draw a nice straight line through all of those if we can. And then just to kind of double check, it's always nice to draw the y equals x line, which will go from corner to corner like that. And that looks like a nice perfect reflection, so feeling good about that one as well. Okay? All right, that's all we have for the, which one is this? The 6.2 worksheet. If you have any further questions on this, please feel free to ask. Thanks.